In this video, we are going to be going over an arithmetic reasoning practice test for the ASVAB. Now, a lot of people get pretty nervous about the arithmetic reasoning portion of it. Reason being because it's not only making you know all the different math knowledge concepts, but it's also combining these math knowledge concepts with a bit of reading comprehension. So your job for this section of arithmetic reasoning is really to try and ask yourself, okay, what is this question actually trying to ask? And then trying to just figure out the quickest way to get to that answer, because again, you're on a limited time, you're on a timed test for this ASVAB test, so it's really all about trying to find the fastest ways possible given the information that you have. So the next thing I also want to remind everyone of is you're only going to get better by actually practicing these yourself. So as we're going through all these different questions, before you see my explanation for it, press pause in the video and actually try it yourself. That's the only way you're going to grow, is if you actually try these out on your own, and then it's going to help you identify the things that you actually do know well and the areas of the test of the arithmetic, reasoning, and other math knowledge concepts that you might need to study a little bit more. So again, I highly encourage you to press pause on the questions after we read them and right before we actually go through the explanations. So without any further ado, let's just go ahead and jump right into it. Question number one seems to be some sort of probability question here. They're asking, there are 5 blue marbles, 4 red marbles, and 3 yellow marbles in a box. All right. If Jim randomly selects a marble from the box, what is the probability of selecting a red or yellow marble? Well, let's draw this out quick. All right. They are giving us a box with a whole bunch of marbles in it, and in particular, there are 5 blue marbles. 1, 2, 3, 4, 5 blue marbles. And then there are 4 red marbles. 1, 2, 3, 4 red marbles. And 3 yellow marbles. 1, 2, 3 poorly drawn yellow marbles. And what they are asking for is, what is the probability of selecting a red or yellow marble? Meaning, like, what is the chance that Jim is going to randomly select either a red marble or a yellow marble? Well, first we need to ask ourselves, how many marbles are in this box total? We have 5 plus 4 plus 3. So 5 plus 4 is 9. 9 plus 3 is 12. So there are 12 total marbles. So out of 12 total marbles, what are the chances that Jim selects a red marble? Well, we can see there are 4 red marbles. So it's going to be a 4 out of 12 chance. There's 12 possible marbles and only 4 of them are red, so randomly selecting a red marble is going to be a 4 out of 12 chance. And then also, what is the probability of selecting a yellow marble? Well, I can put a little plus symbol here, and it's also going to be still 12 marbles. We still are working with the same box of marbles, but this time, what are the chances of selecting a yellow marble? Well, there are 3 yellow marbles, so we can put a 3 up here. And now the chance of selecting a red marble or a yellow marble is going to be the sum of selecting a yellow marble or a red marble, which we already figured out was 4 twelfths and 3 twelfths. And if we remember from adding fractions, as long as the denominators are the same, we can just easily add these together by adding the numerators. So that is going to give us 7 on top, because 4 plus 3 equals 7. 7 is a prime number, meaning we cannot simplify this fraction anymore, so its final state is 7 twelfths. And if we see over here, 7 twelfths is one of the answers, and so we will select C. And we can look at their explanation of how they reasoned that. You can press pause and read that if you want, and we are going to continue on. Next question here. If Kayla has 10.47 tip on a breakfast that cost $87.25, what percentage was the tip? So again, I highly encourage you to press pause here and try and think of the answer on your own. All right, so hopefully you attempted that one on your own there. And let's go ahead and try and solve this one together. So I'll be upfront with you guys. I'm kind of dumb when it comes to these ones. I always forget what way you multiply the tip versus the percentage and the cost and everything else. So let's just try and think of it here. Well, let's say I was given breakfast that cost $100. if I wanted to figure out what tip I wanted to give, right? Like if I wanted to give a 20% tip, what does that look like? Well, I just say 100 times 20%, because that's the tip that I want to give. I want to give 20% of the bill as a tip, and that will equal $20. So we can see that the cost of our meal times the percentage equals the tip there. Well, in this case, what we are given here is we're given the tip, and then we're given the cost. We need to solve for the percentage, so we want to solve for P right here. All right, so let's try and get P all by itself. I'll divide by the cost on this side. I'll divide by the cost on this side. The cost will cancel out, and we can see that in order to find the percentage, what we need to do is we need to say the tip divided by the cost, and that is our formula that we want to use here. We want to say the percentage equals the tip divided by the cost. All right, so what's that going to look like then? We are going to say the tip of $10.47 divided by our cost of $87.25. If we can figure out this percentage here, we can figure out our answer. Well, first, right off the bat, this might be a little bit overwhelming, like, oh my gosh, decimals now, I need to divide by a whole bunch of decimals and everything. Yeah, let's not even worry about that, all right? Decimals suck, I agree with you. Let's just multiply this whole thing by 100 and get those decimal places just right out of there. All right, so I'm going to say this whole fraction here is multiplied by 100. Whatever I do to the top side, I also have to do to the bottom side. So I'm going to move the decimal place over 2 spots on both the numerator and the denominator, because that's what we mean when we say multiply it by 100. We just move the decimal place over 2 spots. So this is going to be 1,047 divided by 8,725. All right, still not a very nice division problem we have to do, but it's at least a little bit easier than working with decimals. So now this is our next task here. This is our next task, and what we need to do here to solve this is use our old friend of long division. All right, so we use this funny bracket here, and we will put the numerator on the inside. And I'm just going to give myself a couple extra decimal places just in case. And then the denominator goes on the outside, so that's the 8725. And now we ask ourselves, can it go into 1? No, it can't. Can it go into 10? No, it can't. Can it go into 104? No. Can it go into 1,407? 1,047? No, it cannot. 8,000 cannot go into 1,000. All right, so can this 8,725 go into 10,470? Yes, it can. We should be able to assume that it is going to go in 1 time. So 1 times 8,725 is going to equal 8,725. All right, we will subtract this. In order to subtract this, we need to make this a 10, which means we need to borrow from our neighbor over here. So this is now a 6 instead. 10 minus 5 is 5. This is a 6, so 6 minus 2 equals 4. 4 minus 7, again, we need to make this a 14 and borrow from our friend. Since our next friend is a 0, we need to borrow from the next one again. So this whole thing here will actually be 9. And now we're saying 14 minus 7 is 4. 9 minus 8 is 1. All right, we need to drop a 0 down. And now ask ourselves, how many times can this 8,725 go into 17,450? Well, let's round this down here, and we'll say 8,000 instead. If it was 8,000, 8,000 can go in here at least once. Can 8,000 go in here twice? Yeah, because 8,000 times 2 is 16. Can 8,000 go in 3 times? No, because that would be too much. That would be 24,000. So let's try it with just 2 times and see if that works here. We might end up saying that's too much and we have to redo a little bit of work, but let's just assume right now that it does it 2 times. It can go in 2 times. We'll say 2 times 5, well, that's going to equal 10. So put the 0 there, carry the 1. 2 times 2 equals 4, plus that 1 is 5. 2 times 7 is 14. Again, we got to carry the 1 and drop our 4. 2 times 8 is 16, plus that 1 is 17. And look at that. That actually worked out perfect there. We have no remainder. So let's put our decimal place back in there. All right, and we can see that our answer here is 12%. So we happen to have 12% over here. And there we go. And again, you can press pause and read the explanation if you want, and we will move on to the next problem here. This one is saying a phone company charges $2 for the first 5 minutes of a phone call and 30 cents per minute thereafter. If Malik makes a phone call that lasts 25 minutes, what will be the total cost of the phone call? So again, press pause here, try this one out on your own, see if you can get the answer, and then we'll go through and work it out together. All right, so hopefully you tried that one out on your own there. Let's work it through together. All right, so again, what are we looking for here? We're looking for the total cost of the phone call. All right, well, we know that the first 5 minutes was $2. All right, the first 5 minutes, I'll say here, the first 5 minutes equals $2. And then it says that every minute after then is 30 cents. So really all we need to figure out here is, well, how many minutes were 35 cents? There's the total phone call was 25 minutes, and we can, ignore the first 5 minutes because that was a fixed rate of $2. So we just need to say 25 minus 5, the whole phone call of 25 minutes, ignoring the first 5 minutes because that was at a different cost. Well, that gives us 20 minutes here. There's 20 minutes that was charged at 30 cents per minute. So if there are 20 minutes and it was 30 cents per minute, to calculate that cost, we're going to say 30 cents times 20. All right, it is 30 cents per minute, and there's 20 minutes. So 30 cents times 20 minutes, that is going to be 3 times 0 is 0. 3 times 2 is 6. We have 1 decimal place in this equation, so I'm going to move my decimal place to 1 spot there, and our answer is 6. So we had $2 for the first 5 minutes, and then $6 for the additional 20 minutes after that. So that's going to be the $2 plus the $6. The total cost for this phone call would have been $8. That should be our final answer. And if we go over here, we see we do have $8 as an option, so that is the letter A. And we will click that one and see their explanation of how they gave that, of how they got that answer there. Let's move on to the next one. Question 4. If 10 inches on a map represents an actual distance of 100 feet, then what actual distance does 25 inches on a map represent? All right, so again, go ahead and press pause and solve this one on your own. All right, so for these type of ones, I like to use cross multiplication here. I like to use cross multiplication and try and represent this problem as equivalent fractions here. So what they're saying is 10 inches on a map represents an actual distance of 100 feet. So if 10 inches is the same as 100 feet, they want to know what would 25 inches be. So that's 25 inches equals how many feet? Equals x. And now it's just cross multiplication. We're going to take the denominator here and multiply it by the numerator over here. So that's going to give us 10x equals this denominator times this numerator. So 25 times 100 is 2500. And now it's as simple as just solving for x. Divide by 10 on both sides. Divide by 10 on both sides. We can make our lives a little bit easier by realizing these 10s cancel out, and then these zeros will cancel out. So we are really just left with x equals 250. 250 feet. So if we go over here, we see 250 is an option. We will select D, and that is correct. They give their explanation there. Let's move on to question 5. All right, 5 years ago, Amy was 3 times as old as Mike. All right, 5 years ago, Amy was 3 times as old as Mike. If Mike is 10 years old now, how old is Amy? All right, press pause and try and get this one on your own. All right, so let's go ahead and try this one together now. And then right off the bat, if you said 30, I'm sorry, but you are wrong. And the reason you are wrong is because age doesn't really work linearly like that. For instance, let's say right now I am 5 years old and my brother is 10 years old. So right now we could say I am 1/2 my brother's age. All right, my brother's age, or another way of saying that is my brother's age is 2 times my age. In 5 years, I will be 10, and in 5 years, my brother will be 15. So we can see I am no longer 1/2 my brother's age. And my brother's age is no longer 2 times my age. So time and age and ratios like that just don't work linearly. So how do we actually solve this instead then? Well, what are we saying here? We are saying that 5 years ago, Amy was 3 times as old as Mike. Remember, that was 5 years ago. So Amy minus 5, her age 5 years ago, was equal to 3 times the age that Mike was, again, 5 years ago. So a minus 5 equals 3 times n minus 5. Well, we know n equals 10, so we can just kind of substitute 10 in here, and we can rewrite this as 10 minus 5. Well, that's going to give us 5. So we'll rewrite the equation here as such, where we say a minus 5 equals 3 times 5. So that's now 15. If we keep on going here, we say a minus 5 equals 15. Add 5 to each side, add 5 to each side, and we are now left with a equals 20. So Amy's age must be 20. All right, we see that as option B here, and that is the correct answer. And we can look through their explanation of how they did that. And we will move on to the next question. Question number 6. At a used bookstore, Valentina purchased 3 books for $2.65 each. If she paid with a $20 bill, how much change would she receive? So press pause and try this one on your own. All right, so hopefully you took a minute to try and solve this one out on your own here. And let's see. She purchased 3 books, and each book was $2.65 each. All right, each book was $2.65, and she purchased 3 of them. So first thing we're going to do is try and figure out, well, what was the total cost of her transaction there? All right, there's 3 books, and they each cost $2.65. So we're just going to say, okay, well, 3 times $2.65 equals 3 times 5 equals 5, carry the 1. 3 times 6 equals 18, plus that 1 is 19, carry the 1. 3 times 2 is 6, plus that 1 is 7. And we had 2 decimal places, so put 2 decimal places back in. So her total cost was $7.95. And now she used a $20 bill to pay with, so 20.00. And the total cost was the $7.95. So we just subtract to figure out what her change was. She gave a 20 and it cost $7.95. We need to figure out what that difference is. All right, so to subtract here, we'll start with our ones column. It's a 0, so we need to borrow from the tens place, which is a 0. So we need to borrow from the hundreds place, which is a 0. So we need to borrow from this 2 here. That becomes a 1. And this becomes a 10, but it's going to be borrowed over there. So that's a 9. This becomes a 10, but that's also going to be borrowed, so that's also a 9. And now this is a 10 here. So now we're saying 10 minus 5 equals 5. 9 minus 9 equals 0. 9 minus 7 equals 2. And then 1 minus 0 equals 1. So her change should be $12.05. And if we see that is an option over here, which is option A, we will click that and see that they gave their explanation there. So moving on to the next one. Maya earns $8.10 per hour, and she worked 40 hours. Charlotte earns $10.80 per hour. How many hours would Charlotte need to work to equal Maya's earnings over 40 hours? All right, so press pause and try this one out on your own. All right, so hopefully you tried that one out on your own. Let's try and go through it together here. So this one might be a little bit confusing with the wording, so let's just try and read the question again. What are they asking here? How many hours would Charlotte need to work in order to equal Maya's earnings over 40 hours? Okay, how many hours does Charlotte need to work to equal Maya's earnings over 40 hours? Well, Maya's earnings over 40 hours was $8.10 per hour for 40 hours. So First, let's figure out what Maya's earnings are going to be, okay? If Maya makes $8.10 per hour, and she works 40 hours, that's just going to be her hourly wage times the amount of hours she worked. Since I have a 0 in the tens place, I'm just going to drop that down and then go directly over to the tens place. 4 times 0 equals 0. 4 times 1 equals 4. 4 times 8 equals 32. And don't forget we had 2 decimal places here. So that is 324. All right, so over 40 hours, Maya makes $324. Now the question is, if Charlotte makes $10.80 per hour, how many hours does she need to work in order to equal 324? All right, well, we see here that with Maya, we said her wage times the amount of hours she works equals, we'll call that G for gross wage here, all right? So hourly wage times hours equals the gross wage. And now what we're asking here for is, in terms of Charlotte, we want to know how many hours she needs to work. So let's solve for hours here. So we will divide by the hourly wage and divide by the hourly wage. We will say the amount of hours equals the gross pay divided by the wage there. All right, so let's just start plugging these back in now. The gross wage we calculated earlier is 324 divided by the wage. In this case, we're wondering what Charlotte's wage is, or how many hours Charlotte needs to work. So we need to use Charlotte's wage. So that is $10.80. All right, and this is going to equal the amount of hours that Charlotte needs to work here. So now let's try and solve this. First and foremost, I hate working with decimal places, so I'm just going to go ahead and get those out of there. I'm going to multiply both sides by 100. All right, and that's going to move this decimal place over 2 spots, get 2 zeros in there, move this decimal place over 2 spots, and that's going to be a new fraction of now 32400 over 1080. We can see we can do a little bit more simplifying here. They both end in a 0, so let's tell them to kick rocks. And it is now 3240 over 108. All right, let's see. These are both even, so let's try and divide both by 2 to simplify it a little bit more. All right, 40 divided by 2 is going to give us 20, and that's going to be 16. Luckily, that works out nicely that we can just do that. And then 108 over 2 is going to give us 54. All right, it is even again, so let's just go ahead and divide by 2 again. That's going to be, what is that? That's 810 on top, and that is 27 on bottom. 810, looks like it should be divisible by 3. I know 27 is divisible by 3. Actually, 810 is divisible by 9 as well. Let's go ahead and let's do 9. That'll be a little bit easier. Divide both sides by 9, because we can do that in mental math, right? 81 divided by 9 is 9, so 890 divided by 9 is 90. And then 27 divided by 9 is 3. And look at that. Now we can do mental math again. 90 divided by 3. Well, 9 divided by 3 is 3, so 90 divided by 3 is 30. So that means Charlotte needs to work 30 hours in order to make the same wage as Maya. So if I go ahead and select D over here, we see that is the correct answer there. And they seem to have worked out in a very similar fashion as we did. So let's go ahead and move on to the next question now. Question 8. Ashaya, am I pronouncing that right? Ashaya wants to paint the walls of a room. She knows that each can of paint contains 1 gallon. A half gallon will completely cover a 55 square feet of wall. All right. Each of the 4 walls in the room is 10 feet high. 2 of the walls are 10 feet wide, and 2 of the walls are 15 feet wide. How many 1 gallon buckets of paint does Ashaya need in order to fully paint the room here? All right, so there's a lot of information here. All right, so you might want to reread what they're asking for. Try and jot down the numbers that you do have, and figure out what information do you need to use or figure out in order to solve the problem. So again, there's a lot of information here. That's what makes arithmetic reasoning a little bit harder of a section to use, because you need to interpret what they're actually asking for here. So go ahead, press pause, and try this one out on your own. All right, so let's try this one together now. Again, there's a lot of information here, so let's just try and dissect it piece by piece. All right, it's saying she wants to paint all the walls in her room, and she knows that each can of paint has 1 gallon in it, and then they're letting us know that, well, a half gallon will cover 55 square feet. So up to this point, all they're really telling us is that she's going to be getting cans, and each can is 1 gallon, but a half gallon will cover 55 square feet. So really, 1 can, we should be able to figure this out here, where 1 can then will cover, because that's 1 whole gallon, and a half gallon covers 55, so 2 half gallons, or a whole gallon, should cover 110. All right, so 1 can will be able to cover 110 square feet. And then they go on saying all sort of the different dimensions here. They say each 4 walls is 10 feet high, 2 of the walls are 10 feet wide, and the other two walls are 15 feet wide. All right, so imagine we have some sort of box here, right? And let's make it 3D. All right, and we have 4 walls here now. And we have 1 wall here. All right, we have a back wall here. We have a side wall here. And then we have a front wall. All right, and they're saying that each wall is 10 feet high. All of these are 10 feet. Those are all 10 feet high. And then 2 of the walls, we'll say this back wall and this front wall, these are 10 feet wide. And then 2 of the other walls, let's say this side wall here and this side wall here, these are 15 feet wide. All right, so what we want to do here is if 1 can equals 110, again, what are we asking for here? We're saying how many 1 gallon buckets of paint does she need to fully paint the room? So we need to figure out, well, how many square feet are in the room, and then given that, how many cans will cover all of that square footage. All right, so first, let's figure out that square footage. We have 4 walls here, and 2 of them are the same. All right, 2 of the walls are the same. So we have 2 walls that are 10 feet high by 10 feet wide. And then we also have 2 walls that are, again, 10 feet high by 15, again, ahead of myself here, 15 feet wide. All right, so let's try and simplify this here. That's plus, I'm gonna do times, I apologize. That's supposed to be times there. All right, so let's simplify this. Remember, PEMDAS, we start with the parentheses. So 10 times 10, that's 100. All right, and that's still times 2, and that's still plus. And then this parentheses here, we have 10 times 15, that is 150. And that's still times 2. Now let's do the multiplication. We have 2 times 100, that is 200, plus 2 times 150, that is 300. 200 plus 300 is 500. So she has 500 total square feet that she needs to cover. And again, we remember that 1 can is 110 feet. All right, so if, I'll draw a little table here, if 1 can is 110 feet, what would 2 cans be? That would be 210. All right, 3 cans would be 220. 3 cans would be 330. All right, we should see that 4 cans would be 440. And then that would mean that 5 cans is 550. All right, so can she do it with 4 cans? Would she be able to cover her room with 4 cans? Well, no, because that's only going to give her 440 square feet. So she would need to buy 5 cans because she has 500 square feet total that she needs to cover. And 5 cans will give her 550. So we look back over our answers here. Answer B is 5, and we click that, and it shows us that it's correct. And then they go through their explanation, which seems to be very similar to ours. So let's move on to the next question now. All right, question number 9. There are 4 red marbles and 8 green marbles in a box. If Emma randomly selects a marble from the box, what is the probability of her selecting a red marble? So we've actually done one very similar to this at the beginning of this test. So press pause and see if you can get this one. All right, so again, it's just another simple probability question here. All right, we're saying we have a box of marbles. All right, Emma has a box of marbles, and 4 of the marbles are red. 1, 2, 3, 4. And then 8 of the marbles are green. All right, so we have 8 of them that are green. 1, 2, 3, 4, 5, 6, 7, 8. 8 green marbles and 4 red marbles. And then we want to know if Emma randomly selects a marble, what are the chances that she'll get a red marble? All right, well, there's 4 of them that are red and 8 of them that are green. How many total are there? There are 12 total marbles. And again, only 4 of them are red. So she has a 4 in 12 chance of selecting a red marble. 4 can go into both the numerator and the denominator, so we can simplify this a little bit and just say that it is 1/3. All right, she has a 1 in 3 chance of selecting a red marble because a third of the marbles are red. So if I go ahead and select A there, we see that as the correct answer, and they give their explanation, and we will move on. Question 10. Oscar purchased a new hat that was on sale for $5.06. The original price was $9.20. What percentage discount was the sale? All right, so press pause and see if you can figure this one out on your own. So let's try and work through this one together here. It's saying Oscar purchased something that was on sale for $5.06. The original price was $9.20. What percentage was the discount essentially? And again, I always get confused looking at these ones, so I like to try and use easy examples so I can remember what the formula is supposed to be here. So let's say I have something that was $100 and I purchased it for only $80. All right, what was my percentage discount here? Well, I could say 100 minus 80 equals $20. Why do I say that? Because that means I saved $20. I saved $20 of the original purchase. So I saved $20 of the original purchase, or I saved 20%. All right, I saved 20% there. So to figure this out, what we need to say is the original price, which I will call P for the original price, minus the discounted price, is going to give us our percentage discount. I will call that, let's just use X, I guess, all right? So we're going to say P minus D equals the X, and then we need to put that X back over the original purchase price, all right? And then we need to say that X over our original purchase price is going to be what our actual discount is going to equal, all right? That's what we want to solve for. All right, so plugging our formulas back in here, our original purchase price was $9.20. All right, our discounted price was $5.06. $5.06. So how much money did we save, or how much money did Oscar save, I guess, rather? All right, so we're going to subtract this here, figure out how much money Oscar saved. Oscar saved, let's see here, we need to borrow from here, so 10 minus 6 is 4, 1 minus 0 is 1, 9 minus 5 is 4. So Oscar saved a total of $4.14. Now, of the original purchase price of $9.20, how much was the savings of that? All right, so it was $4.14 when originally, or savings, when originally it was $9.20. All right. Again, I always hate working with fractions, so I'm going to try and simplify, I always hate working with decimals, rather. So I'm going to try and simplify this. First, I want to get rid of the decimal places and multiply everything by 100, because I think decimal places just makes things a little bit more difficult than it needs to be. So now we are going to say this is 414 divided by 920. All right, I see both of them are even, so I'm going to try and divide by 2 on both sides here, on the top and the bottom. And that will leave me with, what is that? That is 207 on top and 460 on bottom. All right, so now we just have a division problem of 207 divided by 460. So we're going to have to use some long division help over here. Put the numerator inside of 207. I'll give myself an extra couple decimal places just in case. And then the denominator goes on the outside. And now we start asking ourselves, can 460 go into 2? No, it cannot. Can it go into 20? No, it cannot. Can it go into 207? No, it cannot. Can it go into 2070? Yes, it can. How many times can it go in? Let's say 3 here. Let's assume it's 3. So 3 times 0 is 0. 3 times 6 is 18. Carry the 1. 3 times 4 is 12. Plus the 1 is 13. And when we subtract that, we're probably going to get more than 460. So let's try and go one more up, actually. Let's assume 4. Let's say it goes in 4 times. 4 times 0 is 0. 4 times 6 is 24. 4 times 4 is 16, 17, 18. There we go. That looks a little bit closer to what we want here. Now we'll just subtract. 0 minus 0 is 0. 7 minus 4 is 3. 0 minus 8, so we need to borrow from here. 10 minus 8 is 2. And then 1 minus 1 is 0. All right, so now we're going to drop one of these added on zeros down. And now how many times can 460 go to 2,300? 4 times went in that amount. So let's try 5 here. So we'll say 5. 5 times 0 is 0. 5 times 6 is 30. All right, 5 times 4 is 20, 21, 22, 23. So 23, look at that. That comes out beautifully. So our answer is 0.45 or 45%. And if we see, that's one of the options there. So we will select C. And they show us their explanation of why C is the correct answer of 45% there. All right, let's move on. Move on to the next one here. Talking about pizza. All right, my favorite food here. So there are 2 pizza ovens in a restaurant. Oven 1 burns 3 times as many pizzas as oven 2. If the restaurant had a total of 12 burnt pizzas on Saturday, how many pizzas did oven 2 burn? All right, so press pause and try and figure this one out on your own. So hopefully you tried that one out on your own and you saw that it was just a pretty simple algebra problem, really. All right, so they're saying that oven 1 burns 3 times as many pizzas as oven 2. So let's say oven 2 is represented as X. Well, then oven 1 is going to be represented as 3X because oven 1 burns 3 times as many pizzas as oven 2. And then they say that the restaurant had a total of 12 pizzas burnt on Saturday. So if both ovens were working, that would be oven 1, which is 3X, plus oven 2, which is X, equals a total of 12 burnt pizzas that day. And now we want to figure out how many pizzas did oven 2, or X, burn. All right, so again, we just need to solve for X here. It's a simple algebra problem. So 3X plus X equals 4X. And now we say 4X equals 12. Again, solve for X. We just divide by 4, divide by 4. And we will get X equals 3. So oven 2 must have burnt 3 pizzas on Saturday. And we select option B for the answer of 3. And we see that is correct. And they give their explanation, which looks very similar to what we have here. All right, moving on. Next question, question number 12. Sophia is driving to Texas. She travels at 70 kilometers per hour for 2 hours and 63 kilometers per hour for 5 hours. Over the 7-hour time period, what was Sophia's average speed? All right, we want the average speed over this time period. So go ahead and press pause and try this one out on your own. All right, so this one, again, what are they asking for? They're asking for Sophia's average speed. The average speed over the 7-hour time period. All right, remember how we calculate average. We add up all of the items in our data set and then divide by the total number of items that we had in the data set. All right, so in this case, we have 7 total hours. So we know that it's going to be something divided by 7 because there are 7 total hours. Well, what is that something? Let's add up all the hours, add up all the kilometers and hours that we're trying to average here. So two of the hours were at 70 kilometers per hour. All right, and then there were 5 hours that were at 63 kilometers per hour. So 5 times 63. All right, now we just need to solve this equation here. 2 times 70 plus 5 times 63. 2 times 70, that's going to be 140. And then 5 times 63, let's see. Multiplying anything by 5 is the same as multiplying anything by 10 and then dividing it by 2. So let's try and do some mental math here. 10 times 63 is 630. And then half of 630, that's going to be 315, which means 5 times 63 is going to be 315. And that's this whole thing still divided by 7. Let's simplify the numerator. Again, doing some mental math here. 140 plus 315, that's going to be 455. 455 divided by 7. I cannot do that one in mental math, so we need to do some long division here, where we put the numerator inside and the denominator outside. Can 7 go into 4? No, it cannot. Can 7 go into 45? Yes, it can. It can go in 6 times. 6 times 7 is 42. And we subtract and we get a 3. Drop the 5 down. Can 7 go into 35? Yes, it can. It can go in 5 times because 5 times 7 is 35. And we subtract and we get no remainder. So our answer is 65. That was 65 kilometers there. All right. And they go and give their explanation, which, again, looks very similar to ours here. And there we go. Moving on to the next question here. Question number 13. Stephen signed up to bring 5 gallons of lemonade to the company picnic. He has a 5-gallon bucket, which contains 3.5 gallons of lemonade. How many pints of lemonade does he need to add in order to fill the bucket? All right, so take a moment to try this one out on your own, and then we'll go through it together. All right, so hopefully you tried that one out on your own, but it might have gotten a little bit confusing because they're changing it up on us a little bit. They're saying that Stephen has, all right, or Stephen signed up rather. All right, let's draw a diagram here to really see what they're saying here. All right, Stephen signed up to bring 5 gallons of lemonade to the picnic company. Well, luckily he has a 5-gallon bucket. All right, this whole bucket can contain 5 gallons. All right, but his 5-gallon bucket only contains 3.5 gallons of lemonade. So he's short. How much is he short here? Well, the entire bucket can hold 5 gallons, and he's supposed to bring 5 gallons. He only has 3.5 gallons, so he needs just 1.5 gallons of lemonade. That's what they're asking for. But they're not actually asking that. They're asking for how many pints will he need to fill the bucket. And it's like, man, who cares how many pints? We know he needs 5 gallons, right? We know that he just needs 5 gallons, but they go and ask for pints, so they try and trick you a little bit. So it's your job to hopefully know how many pints are in a gallon. And, well, 1 gallon is equal to 8 pints. All right, 8 pints are in a gallon. So all we need to do here is knowing that we need, or Stephen needs 1.5 gallons, and then to convert that to pints, we just need to multiply that by 8. So 8 times 5 is 40, carry the 4. 8 times 1 is 8, plus that 4 is 12. We had 1 decimal place here, so put the decimal place back in. So Stephen needs 12 pints to fill up that 5-gallon bucket. And that's how you would solve that one. We click on 12, and we see that is the correct answer there. Like they give you even more information, so I'll try and remember going into the test that there are 4 quarts in a gallon. All right, so he'll need 6 quarts, and then there are 2 pints in a quart, so he'll need 12 pints there. All right. So try and remember all those different unit conversions prior to going into the test. So let's try and move on to the next question here. If a car travels 360 kilometers in 5 hours, how many kilometers will it travel in 9 hours when driving the same speed? So again, I encourage you to press pause and try this one out on your own. So let's try this one together here. All right, so if a car can travel 5 hours and get 360 kilometers, then if they're traveling 9 hours, how many kilometers will they travel? And to me, this seems like some sort of ratio or proportion problem, and I like to use cross multiplication to solve these type of ones. So for every 5 hours they went, they can get 360 hours. So if kilometers. So if they go 9 hours instead, well then how many kilometers could they get? And again, we're just going to do some simple cross multiplication here. Take the denominator here, multiply by the numerator there, denominator there, multiply by the numerator there. That's going to give us 5x equals, I can't do that one in my head, so I'm going to do 360 times 9 over here. 9 times 0 is 9, 9 times 6 is 54, carry the 5, 9 times 3 is 27, 28, 29, 30, 31, 32, so that is 32, so that is 3240. All right, now we are going to divide both sides by 5. Again, not something I can easily do in my head, so I'm going to use our good old friend of long division here, where the numerator goes inside 3240 with the denominator on the outside. 5 goes into 32 6 times, and that will give us 30. That remains your 2. Drop down the 4. 5 goes into 24 4 times. That gives us 20. Subtract, you get 4. Drop down the 0. 5 goes into 40 8 times, because 8 times 5 is 40. Subtract, and we're left with 0. So our final answer is x equals, because those will cancel out, and we just calculated this equals that, so 648. So x equals 648, which is what we were trying to find in the first place. So driving 9 hours at the same rate, that would be 648 kilometers. And we see that is the correct answer, and they give their explanation for that as we see there. Moving on to question 15 here. Almost done, folks, almost done. Maya purchased a boat for $18,340. Its value depreciated by 15% in the first year she owned it. What was her boat worth at the end of the first year? All right, so press pause and try to solve this one on your own. All right, so let's work through this one together now. All right, so it's saying she purchased a boat for $18,340. And then in that first year, it depreciated by 15%. So meaning like it's now worth 15% less. So 50% of the original purchase is now worth that amount less than that original purchase. All right. So first we need to figure out, well, what is 15% of the original purchase? All right. So 15%, what we need to say here is 18,340 times 15%, or another way of doing that is 18,340 times 15 over, let me draw that a little bit better. There we go. 15 over 100, because 15 over 100 is the same thing as 15%. And again, multiplying fractions here, we can just multiply the numerators and multiply the denominators. All right, so now we need to do 18,340 times 15. All right, 18,340 times 15. All right, that's going to give us 5 times 0 is 0. 5 times 4 is 20. 5 times 3 is 15, 16, 17. 5 times 8 is 40, 41. 5 times 1 is 5, plus the 4 is 9. Move on to the tens place, we drop our 0. 1 times 0 is 0, 1 times 4 is 4, 1 times 3 is 3, 1 times 8 is 8, and then 1 times 1 is 1. And now we add these together, we get 0, 0, 13, 5, 17, and 2. All right, so now it is 275,300 divided by, that was that part here, and now the numerator or the denominator is 1 times 100, so it's just 100. And we can simplify that to just 2, cross off the 2 zeros here, cross off the 2 zeros there, and that simplifies just 2,753. All right, so 2,753 is 15% of the original purchase price. All right, but that's not what they're asking. They're asking for what is the boat price worth at the end of the year. Remember, it decreased by this amount. It decreased by this 15%. So now we need to say the original boat price of this 18,340, well, it decreased by 15%. So it decreased by this 2,753. So now we just need to subtract these. It's just a simple subtraction problem now. All right, we need to borrow from the tens place. So now it's 10 minus 3. That'll give us 7. We need to borrow again from the hundreds place, and now it's 13 minus 5, which equals 8. We need to borrow again. So that is 7 now, and that'll be 12 minus 7 is 5. 7 minus 2 is again 5, and 1 minus nothing is also 5. So that'll give us our total cost of the boat after the first year by depreciating of 15% will equal 15,597. I have 15,598 there, or 89. Let's see, where did the math come out wrong here? I'm being silly here. My math came out wrong right about here. Hopefully a lot of you caught that. 7 plus 4 is actually 11, not 13. It is 11. So that means that should be a 1 there, not a 3. That should have been a 1, not a 3. And that means this is a 1, not a 3, which means this would be a 9, not a 7. And there we go. So silly little mistake, hopefully. Luckily, it was on the ones place, so it wasn't that detrimental. But that would be our final answer there of D. And that is the correct answer. And yeah, they give their explanation there. I do like this, what they're saying here is an easier way to recognize that the boat will still retain 85% of its value. What are they saying there? Again, it depreciated by 15%. It is now worth 15% less. So at the beginning of the year, it was worth, well, 100%. At the beginning of the year, it was worth 100%. And then it lost 15%. So if you have 100% of something and then you lose 15% of something, well, now you have just 85% of something. So I suppose an easier way of doing that would have been to realize that, well, the boat's now worth only 85% of what it used to be worth. So we also could have just done that 18,340 times 85%, and that might have saved you an extra step or two if you were to do it that way instead. So that's also another great way to sort of think of the problem. But all right, let's move on to the next example here. The final question here. Radar system beeps once every second. How many times will it beep in 3 days? All right, so press pause and try and think of this one. Try and solve this one on your own. All right, so let's go ahead and try this one out together now. So a radar system beeps once every second. So every single second, it's going to annoyingly beep every second of every single day, 24/7. All right, so how many times will it beep in 3 days? So really, what they're just asking for is how many seconds are in 3 days. All right, in order to do that, well, we know that in 1 minute, there are 60 seconds. So there's 60 seconds in every minute. So if there's 60 seconds in every minute, how many seconds are there in every hour? Well, there's 60 minutes in an hour. So 60 times 60 is going to be, that's just 6 times 6 with 2 zeros, so 36. So there are 3,600 seconds per hour. All right, that's per hour. Well, there are 24 hours per day. So in order to convert this to days, we just need to multiply this by 24 now. And we're just going to go ahead and multiply all the way through. 4 times 0 is 0. 4 times 0 is 0. 4 times 6 is 24. 4 times 3 is 12. Plus that 2 is 14. We're moving on to the tens place, so we drop a 0. And then 2 times 0 is 0. 2 times 0 is 0. 2 times 6 is 12. 2 times 3 is 6, plus the 1 is 7. And then we add 0, 0, 4, 6, and 8. So there are 86,400 seconds in a day, and that's how many per 1 day. We are given 3 days here, so now we need to do this 86,400 times 3. All right, that's going to be 0, 0, 2, 12, carry the 1. 3 times 6 is 18. So 8, carry the 1. Oh, sorry. 18 plus that 1 is 19. So 9, carry that 1. 3 times 8 is 24. Plus that 1 is 25. So in 3 days, that stupid radar system is going to beep, and annoyingly, 259,200 times. So we can see that that is answer D right there. We will click on that one. And that is the correct answer, and they give the explanation very similar to what we have there. So there you have it, folks. Let me know in the comments section, how many of these did you get correct by trying it on your own? Drop it down in the comments. If you liked this video, please do click that like button. If you like this type of content and want to learn more about the mathematics and arithmetic reasoning sections on the ASVAB, please hit that subscribe button. I also have a couple playlists of different topics that, again, all revolve around the different math sections on the ASVAB. So press subscribe, and I'll see you all next time.